student of final year Environmental Science and Technology, SROF, SR Rotary Institute of Chemical Technology. Our project ID is 131873. The topic of today's presentation is removal of color and COD from the textile industrial wastewater using the electrocoagulation process. Our project is guided by Ms. Anjali Nair, Assistant Professor, Environmental Science and Technology. Need of this study is textile industry is one of the most polluting industry in terms of volume and complexity of treatment of its effluent discharge. The effluent is characterized by the high level of color caused by the residual dyes, COD, salt content, high temperature, and broad range of pH. The colored wastewater released into the ecosystem is also the dramatic source of aesthetic pollution and the pollution in the aquatic life. Using electrocoagulation, the formation of secondary pollutant. That is why electrocoagulation has gained more interest than the biological treatment. Next, continue by the Adrija. Please, Adrija.
Thank you, Janki. Now the issues in textile industries. Textile industry is one of the most polluting industries in terms of volume and complexity of treatment of its effluent discharge and is categorized by high levels of color caused by residual dyes, COD, salt content, high temperature, and broad ranges of pH. Using electrocoagulation, the contaminants present in wastewater are stabilized in solution without the formation of secondary pollutants. Also, it offers a better solution to large quantities of effluent to be treated, as in this process, continuous flow regime is used. Electrocoagulation also contributes to coagulation by neutralizing the negatively charged particle. Now, the proposed solution we offer, the proposed solution is to investigate the influence of operating parameters on COD and color removals from a simulated textile effluent using electrocoagulation using metal such as aluminum or iron in continuous mode. Now, further will be continued by Smith.
So electrocoagulation continuous upflow process. So it has been successfully used for the treatment of textile wastewater, being attractive for its uniqueness, safety, selectivity, ease of control, and environmental compatibility. It involves the generation of coagulant in situ by the dissolution of metal ions from the consumable anode with the simulation formation of the hydroxide ion at the cathode. Instead of using chemicals and microorganisms, electrons are employed agents in ECF, being responsible for facilitating wastewater treatment. A simple ECF unit essentially involves an electrochemical cell, two electrodes as an anode, and a DC power supply. Now, the expected outcomes are the minimum time consumption. As per the research paper in continuous process, the efficiency of COD removal was only 76% and color removal efficiency was around 95% at a time interval of 15 to 20 minutes. Whereas in the batch process, the efficiency of COD removal was 87% and the color removal is 88% at the time interval of 120 minutes. So we try to maximize the efficiency in continuous process. Now the procedure. So we took the 1500 ml of untreated textile effluent in a 2-liter beaker, then kept this beaker in the reactor setup with a pair of electrodes, turned on the DC linear power source. After we tabulated the psychochemical characteristics of the wastewater, along with the average values, COD was measured at the interval of consecutive 10 minutes till pseudo steady state was achieved by closed reflux calorimetric method. Voltage was used for the operating parameter and corresponding current is recorded. And on the basis of corresponding current measure operating variable J is calculated. That is J is equals to I upon S into A. Now the conclusion would be continued by Harsh.
Conclusion. The COD and color removal of textile water was affected by current density, detention time, and times of electrolysis. Our results showed that unilateral increase in J, dt, and times of electrolysis would not assure higher COD removal for this type of textile water. For textile water with concentration of 350 mg per liter, COD and color removal of 84% and 90% respectively. Thank you.